what if the most frightening part of going to Mars is not the launch, not the fire beneath the rocket, not the months drifting through empty space, not even the landing when a spacecraft screams into the thin Martian atmosphere with no room for hesitation? What if the real terror begins after everything has gone right? After the engines have worked, after the parachutes have opened, after the heat shield has survived, after the first human boots press into red dust. Because that is the version of Mars we rarely imagine. We picture the arrival, the flag, the first words, the historic photograph, the astronaut standing beneath a pale salmon sky with Earth somewhere behind them, impossibly far away. But we do not always picture what comes next. We do not picture the silence after the celebration, the habitat door closing, the dust settling, the crew looking back at the sky and realizing that Earth is no longer a place they can simply return to. For decades, Mars has been described as humanity's next great step, the destination after the moon, the world that waits just close enough to seem possible, but far enough away to feel heroic. Governments have studied it, space agencies have planned for it, private companies have promised it. Engineers have drawn the rockets, the habitats, the landing systems, the fuel plants, the domes, the greenhouses. And slowly, Mars has become more than a planet. It has become a symbol of survival, a symbol of ambition, a symbol of humanity refusing to remain trapped on one fragile blue world. But here's the problem. A mission to Mars may not be a mission in the way most people imagine. It may not be a journey where humans go, explore, collect samples, take photographs, and then come home to applause. It may be something much older, much harsher, and much more permanent. A crossing, a departure, a one-way passage into a place that changes the meaning of home. The first humans who travel to Mars may not be explorers in the familiar sense. They may be the first people in history to leave Earth knowing, somewhere deep inside, that the door behind them might never open again. Not because they lack courage, not because technology fails in one dramatic moment, but because Mars places every part of the return journey under pressure: physics, fuel, biology, time, money, psychology, and isolation. Each problem alone is difficult. Together, they form something far more unsettling: a chain. And every link in that chain pulls the crew farther from Earth. This is why Mars is so deceptive. From a distance, it looks almost reachable. It is close compared with the stars, close compared with the outer planets, close compared with the black ocean of interstellar space. It is a small red world orbiting in our own solar neighborhood, visible in the night sky, familiar enough that humans have dreamed about it for more than a century. It has seasons. It has polar ice. It has mountains, valleys, plains, ancient riverbeds. It has a day not wildly different from our own. In images, it can almost look like a desert on Earth after all the life has been removed. And that is what makes it dangerous to the imagination. Because Mars looks like a place we could visit, but it may actually be a place we have to surrender to. The moon taught us a certain kind of confidence. Humans left Earth, crossed space, landed on another world, and returned. The story had a beginning, a crisis, and a homecoming. It proved that the impossible could become possible with enough engineering, enough money, enough focus, and enough courage. So it is tempting to think Mars is simply the next version of that story. A longer Apollo, a harder Apollo, a red Apollo. But Mars does not belong to that kind of story. The moon is near enough that the human mind can still hold the journey. A few days there, a few days back. Communication almost instant. Earth large in the sky. Home still close enough to feel real. Mars is different. Mars is months away, and not just months away in distance, months away in consequence. Months of recycled air, stored food, artificial light, mechanical noise, and the knowledge that every day Earth is becoming smaller. Months where there is no rescue spacecraft waiting nearby, no quick return path, no easy abort, no turning the mission around like a ship at sea. Once the crew is committed, the solar system itself begins to decide what is possible. That is the part most people do not feel when they hear the phrase going to Mars. They imagine travel. But interplanetary travel is not like travel on Earth. You do not choose a road and leave when you want. You move between worlds that are constantly orbiting the sun at different speeds, separated by distances that change every moment. The planets must be positioned correctly. The launch window must open. The mathematics must permit the journey. And if the timing is wrong, Mars does not care. It simply keeps moving. So does Earth. And the humans caught between them must wait. This means the first people on Mars might not be able to leave when they feel ready. They might have to remain there until the sky itself offers a path home. And during that wait, Mars stops being a destination and becomes an environment, a place that must be endured, repaired, powered, pressurized, warmed, and survived. Every breath must be managed. Every drop of water must be protected. Every system becomes sacred because every system is life support. On Earth, survival is hidden inside the planet. The atmosphere does the breathing for us. The oceans hold the water. The soil grows the food. The magnetic field and atmosphere shield us from much of what space throws our way. We walk through all of this protection so casually that we forget it exists. On Mars, nothing is hidden. The protection has to be built. The air has to be contained. The heat has to be generated. The water has to be found or recycled. The food has to be stored or grown. The walls have to keep death outside every hour of every day. And then comes the question that sits quietly beneath the entire dream. After all of that, how do you come back? How do you lift humans off Mars, send them across millions of miles again, protect their bodies from radiation and gravity loss, guide them back through Earth's atmosphere, and return them safely to the world that made them? That question sounds simple. It is not. It is the question that turns Mars from an adventure into something much darker. Because going to Mars is hard. But returning from Mars may be the part that makes the entire dream almost impossible. Tonight, we begin there with the uncomfortable possibility that the first humans on Mars may not be visitors at all. They may be settlers. They may be founders. They may be people who trade oceans, forests, rain, open air, and the gravity of Earth for a red horizon they will see every day for the rest of their lives. And by the end of this journey, Mars may no longer feel like the next moon. It may feel like a door, one that opens only once and closes behind the people brave enough to step through it. Mars has always looked close enough to tempt us. Not close in the human sense. Not close like a city across a border or an island across an ocean or even the moon hanging only a few days away. But close in the strange language of astronomy. Among the worlds of the solar system, Mars sits almost within reach. It is not a distant ice giant lost in the dark. It is not a crushing furnace like Venus. It is not a moon buried beneath the radiation belts of Jupiter. It is a rocky planet, moving around the same sun, sometimes shining in our night sky as a red point of light that seems to be waiting for us to notice it. And we have noticed it for a very long time. Mars has always invited projection. Before spacecraft reached it, before orbiters mapped its canyons and rovers crossed its plains, humans looked through telescopes and imagined a world of canals, dying seas, ancient beings, hidden cities, and intelligent life struggling beneath a fading sky. Most of those ideas were wrong. Some were illusions. Some were fantasy. Some belonged more to literature than science. But the emotional pull was real. Mars was the first alien world that seemed almost understandable. Not friendly, just understandable enough. That is an important distinction, because the more we learned about the solar system, the more Mars stood out, not because it was safe, but because everything else was so much worse. Look inward toward Venus, and the dream collapses quickly. Venus is nearly Earth-sized, but its beauty is a disguise. Beneath its clouds is a surface hot enough to destroy most machines, an atmosphere so dense it would crush unprotected structures, and a pressure cooker world where landing is not exploration so much as endurance until failure. Look outward toward Jupiter and Saturn, and the scale becomes monstrous. They are magnificent, but they are not places for humans to stand. They are giants of gas and storm, wrapped in violent atmospheres and deep gravity wells. Their moons may hold mysteries, oceans, chemistry, maybe even the ingredients of life, but they are far colder, farther away, and harder to reach. Mars, by comparison, offers a terrible kind of hope. It has ground. That alone matters more than it should. A surface, a horizon, rocks, dust, mountains, valleys, frozen water, ancient river channels carved into the land like memories of a warmer planet. When we see Mars through rover cameras, it does not look like a place completely beyond human imagination. It looks like a desert after something has gone wrong. A desert emptied of plants, sound, and breath. A landscape that feels almost familiar until you remember that no human could stand there without a suit. That almost is what makes Mars so powerful. Almost Earth-like, almost reachable, almost survivable. But almost is not enough to keep a person alive. Mars is colder than our instincts want to believe. Its atmosphere is thin, mostly carbon dioxide, and far too weak to support human breathing or protect the surface the way Earth's atmosphere does. The pressure is so low that liquid water is unstable on the surface under ordinary conditions. The sky may glow softly, but it does not shelter you. The soil may hold ice, but not a river you can kneel beside and drink from. The day may be close to Earth's in length, but the world itself is profoundly alien. This is the trick Mars plays on the mind. It gives us just enough similarity to make us forget the abyss of difference. A day that feels familiar. A landscape that has horizons. A planet where a sunrise could be watched. A world where a human footprint could remain in dust. But beneath that familiarity is a place that does not support life naturally. There is no open air, no rain, no forest, no ocean, no insects moving in the grass, no background softness of biology, no living world repairing itself around you. On Earth, even the harshest deserts are alive compared with Mars. There are microbes, winds carrying spores, buried roots, insects, water hidden in rock, animals moving at night, plants waiting for rare rain. Earth's deserts are difficult, but they are still woven into a planet that breathes. Mars does not breathe that way. Mars is a memory of processes without the comfort of life. It has weather, but not climate in the human sense. It has dust storms that can grow across enormous regions. It has seasons, but not spring as we understand spring. It has ice, but not the blue living cycle of oceans and clouds and rivers, returning water again and again to the land. And yet, because it is not completely impossible, we keep returning to it. With telescopes, with orbiters, with landers, with rovers, with plans, with promises. Each mission has made Mars more real and somehow more haunting. The closer we get, the less it becomes a fantasy world, and the more it becomes something stranger. A place that once may have been more alive than it is now. A world where water flowed. A world where lakes may have rested under open sky. A world that perhaps held the conditions for life long ago, before its atmosphere thinned, before its magnetic protection faded, before its surface became the cold, irradiated desert we see today. That ancient Mars is part of the dream too, because we are not only drawn to Mars as a future, we are drawn to it as a ruin, a planet that may have lost something. And when humans look at a ruin, we do not only see what is there, we imagine what used to be there. We fill empty windows with voices. We turn dry riverbeds into flowing water. We look at red dust and imagine blue lakes. We look at silence and imagine that maybe, once, Mars had a story closer to ours. That is why it is so easy to believe we are meant to go there. Mars feels like a world waiting for an answer. But the question is not simply whether humans can reach it. We can probably reach it. The deeper question is what kind of bargain Mars demands once we arrive. Because Mars may be the most inviting, hostile world in the solar system. It offers just enough promise to pull us forward, and just enough danger to make return uncertain. It gives engineers something to work with: ice, carbon dioxide, sunlight, surface, gravity, but never enough to make survival simple. And that is where the first illusion begins to break. Mars looks like the next moon because it is nearby, rocky, and visible. But the moon was a place humans visited. Mars may be a place humans have to inhabit. The moon let us come home quickly. Mars may ask us to stay long enough that the word visit loses its meaning. So before we talk about rockets, fuel, radiation, or the human body slowly changing in another world's gravity, we have to understand this first. Mars is dangerous precisely because it looks possible. Not impossible enough to ignore. Not friendly enough to trust. A world close enough to dream about. And far enough away that the dream may become a life sentence. The moon taught us the wrong lesson. Not because Apollo was easy. It was not. Apollo was dangerous, expensive, fragile, and astonishing. It required thousands of people, entire industries, new machines, new mathematics, new materials, and a level of national focus that almost seems impossible from a distance now. Every mission balanced on the edge of failure. Every launch carried human beings into an environment that would kill them immediately without machinery. But Apollo also gave us a story that was too clean. A rocket leaves Earth. A crew crosses space. A lander descends. Humans step onto another world. Then they come home. That last part matters. They come home. It is what made Apollo feel complete. The astronauts did not simply vanish into the sky. They returned as proof that the journey had been survivable. They splashed down in Earth's ocean. They breathed Earth's air again. They stood under Earth's gravity again. The circle closed. And because that circle closed, we inherited an assumption. If we could do that with the moon, then Mars must be the next version of the same achievement. Bigger rocket, longer flight, more supplies, more money, same basic story. But that is where the illusion begins. Mars is not Apollo with extra distance. Mars is a completely different kind of problem. The moon is about 240,000 miles from Earth. That number is large by human standards, but in space, it is almost intimate. Light crosses that distance in a little more than a second. Radio communication is delayed, but barely. Astronauts could talk to mission control with pauses that still felt like conversation. Earth was not just visible from the moon, it dominated the lunar sky. Home was distant, but psychologically present. Mars breaks that connection. On the way to Mars, Earth does not remain a world in the window. It shrinks, slowly, almost cruelly. At first, it is still recognizable blue, white, alive. Then it becomes a bright disk, then a dot. Eventually, it becomes just another point of light among countless others, except this one contains every ocean, every city, every person the crew has ever loved. That is not just distance. That is emotional geometry. Apollo astronauts could look back and see the whole Earth hanging there, close enough to feel like a destination waiting for them. A Mars crew would watch Earth become something else, not a place beneath their feet, not a world in the sky, but a memory with coordinates. And the travel time changes everything. Apollo missions lasted days. A Mars mission begins with months. Months inside a sealed spacecraft where every sound repeats: the hum of fans, the cycling of pumps, the small noises of other people moving in confined space, the same walls, the same equipment, the same routines, the same recycled air moving through the lungs again and again. There is no stepping outside. There is no fresh wind. There is no private walk under an open sky. There is only the spacecraft, the crew, and the expanding silence between planets. In Apollo, danger was compressed. The timeline was short enough that supplies could be carried, systems could be simplified, and endurance could be measured in days. If something failed, the crew still had the possibility of improvising their way back within a limited window. Mars stretches danger into habitat. A 6 to 9 month journey is not just a trip, it is a temporary world. The spacecraft must become home, shelter, workplace, hospital, gym, dining room, sleep chamber, and lifeboat all at once. It must keep humans alive while traveling through deep space, beyond the constant protection of Earth's magnetic field, through radiation that does not care about ambition. And then, after all that, the crew has not completed the mission. They have only arrived. That is the psychological trap hidden inside Mars. With Apollo, landing on the moon was the climax. With Mars, landing is closer to the beginning of the real test. The crew descends after months of confinement, weakened by microgravity, carrying the stress of distance, radiation, and isolation, and then must immediately survive on a planet that offers almost nothing for free. The moon was a place to visit briefly. Mars is too far away for briefness. This difference changes the meaning of every system. On the moon, a lander could be minimal because the stay was short. On Mars, a habitat must endure. On the moon, the crew could bring almost everything needed. On Mars, everything becomes heavier, more complicated, and more permanent. On the moon, a mistake was terrifying. On Mars, a mistake may become a colony-wide problem with no one close enough to help. Even communication changes the emotional texture of the mission. Apollo had mission control almost beside it in time. The voices from Earth were delayed by seconds. A question could be answered quickly. A problem could be discussed almost as it happened. Mars does not allow that kind of closeness. Depending on the positions of the planets, a message can take several minutes to reach Earth, then several minutes for the reply to return. That may sound small until something is breaking, until pressure is dropping, until a pump has failed, until a crew member is sick. until a warning light appears, and no one can wait for Earth to think. A Mars crew cannot be guided second by second. They must become their own mission control. That is a profound change. Apollo astronauts were explorers supported by an entire planet in near real time. Mars astronauts would be something more isolated, more autonomous, and more vulnerable. They would still hear from Earth, but not like a voice beside them, more like messages from the past, arriving across a gulf that cannot be shortened by worry. And then comes the cruelest difference. The Moon did not trap us. Mars can. On the Moon, the crew could leave soon after landing. The return stage was there, the timing was manageable. The journey home was days away. On Mars, arrival does not mean the return journey is available. The planets move, the window closes, the geometry shifts. A crew standing safely on the surface may still be unable to leave because the solar system is not arranged for their return. That single fact breaks the Apollo myth completely. Because Apollo was a visit, Mars is a commitment. Once humans land there, they may have to stay not for hours, not for days, not for a symbolic moment, but for hundreds of days before a path home even becomes efficient again. And during that time, Mars stops being a stage for history and becomes the entire environment of life. The red sky becomes ordinary. The habitat becomes the world. The suit becomes the doorway outside. Earth becomes a signal. This is why Mars cannot be understood as the next moon. The Moon showed that humans could touch another world and return. Mars asks whether humans can leave one world long enough that returning becomes uncertain, expensive, dangerous, and maybe no longer the main point. And that leads us to the first real trap. Not the rocket, not the landing, not even the thin air or the freezing dust. The trap is movement itself. Because once you reach Mars, the question is no longer simply whether you survive the journey. The question is whether the universe will allow you to come back when you want to. Here is the part of Mars travel that feels almost unfair. Even if the spacecraft works perfectly, even if the crew survives the months in deep space, even if the landing succeeds, even if every human being steps onto the Martian surface alive, they still cannot simply decide to come home. That is not how planets work. On Earth, movement feels personal. You choose a direction. You leave when you are ready. A road, a train, a ship, an aircraft, all of them obey human schedules closely enough that travel feels like a decision. But interplanetary travel is different. In space, timing is not a convenience. Timing is the mission. Earth and Mars are not fixed points separated by a static distance. They are moving worlds, each falling around the sun at its own speed, tracing enormous paths through space while constantly changing position relative to each other. Earth completes one orbit around the sun in 1 year. Mars takes almost twice as long. That means sometimes Mars and Earth are relatively close. Sometimes they are on opposite sides of the Sunday. And most of the time, they are somewhere in between, moving through a geometry that no human desire can rush. You do not launch to Mars whenever you want. You wait for the solar system to line up. This is why Mars missions depend on launch windows' rare periods when Earth and Mars are positioned so a spacecraft can travel efficiently between them. The usual approach is not to point directly at Mars as it appears in the sky. If you did that, Mars would not be there when you arrived. Instead, you launch toward the place Mars will be months later, like throwing a stone across a moving river toward a target that has not arrived yet. It is elegant, it is beautiful, and it is merciless. Because once that window closes, the energy required to make the trip rises sharply. You can still imagine more extreme trajectories, more fuel, faster routes, more complicated plans. But every improvement demands something: more mass, more power, more risk, more cost. So mission planners wait. They wait for the sky to permit the journey. And that same rule applies in reverse. Once humans are standing on Mars, the return journey is also controlled by orbital alignment. The planets must again be in the right positions. Earth must be reachable in a way that does not demand absurd amounts of fuel. The spacecraft must depart not when the crew feels homesick, not when someone becomes frightened, not when a system begins to fail, but when celestial mechanics opens the door. That is the trap. Mars can be reached, but Mars does not let you leave on your own emotional schedule. Imagine the psychological weight of that. You are standing on another planet. The sky is pink and dusty. Your habitat is behind you, humming quietly, holding the only breathable air for millions of miles. Somewhere in the sky is Earth, but you cannot see the people there. You cannot hear them in real time. You cannot step outside without a suit. You cannot take one unplanned walk. You cannot open a door and feel weather on your skin. And even if everything inside you wants to return, you may have to wait. Not days, not weeks, possibly hundreds of days. A mission that looked like exploration begins to resemble confinement. The planet becomes not just a destination, but a waiting room built from dust, metal, machinery, and mathematics. This is where Mars becomes emotionally different from almost any journey humans have ever attempted. On Earth, even the most isolated expeditions usually have a season of return. Antarctic crews endure the winter, knowing the ice will eventually allow aircraft or ships to come back. Submarine crews know the mission has an end. Astronauts aboard space stations know a capsule is nearby, and Earth is only hours away. But on Mars, the end is not nearby. The end is an orbit. An orbit does not care about fear. If the crew misses the return window, the consequences are not minor. You do not simply wait for the next flight tomorrow. The next favorable opportunity can be many months away. A delay can stretch the mission dramatically, turning a difficult stay into a much longer one. Supplies must last. Equipment must keep working. Bodies must keep enduring. Minds must keep holding together. A missed window is not just a scheduling failure. It is another sentence added to the mission. This creates a strange kind of dependency. The crew depends on machines, yes. They depend on fuel, power, water, food, oxygen, radiation shielding, and each other. But they also depend on the motion of planets they cannot control. Their lives are tied to a clock larger than humanity. A clock made of gravity. That is what makes the orbital trap so unsettling. It is not dramatic in the way movies prefer. There is no monster, no explosion, no villain. Just two planets moving through space, indifferent to the human beings trying to cross between them. And yet that indifference may decide everything. Because a Mars mission is not simply go there and come back. It is go there when the planets allow it, survive until the planets allow departure, then return along a path the planets permit. The mission is less like a road trip and more like stepping onto a moving bridge that appears only rarely, then disappears behind you. Once you understand that, the idea of Mars as a quick visit begins to collapse. A short surface stay becomes difficult. A fast return becomes expensive. A rescue becomes almost fantasy. And the crew begins to look less like visitors and more like people trapped inside a long rhythm of celestial mechanics. But even if the window opens again, even if Earth and Mars line up, even if the crew is ready, the habitat is working, and everyone has survived the wait, one question remains. How do you actually leave? How do you lift human beings off a planet push them back into space, and send them across the Gulf to Earth. That is where the next nightmare begins. Because the return journey is not only a matter of timing, it is a matter of fuel. Once the return window opens, another question appears. A colder question. Not when can they leave Mars, but how? Because leaving a planet is never simple. It is one of the hardest things any machine can do. A rocket does not merely rise. It fights gravity. It carries its own energy. It burns mass to throw itself upward, and the faster it needs to go, the more fuel it needs to carry. But fuel is not weightless. Fuel is part of the burden. And that is where spaceflight becomes cruel. Every kilogram of fuel added to a spacecraft makes the spacecraft heavier. A heavier spacecraft needs more fuel to move. That extra fuel makes it heavier again. The problem folds back on itself. It grows. It multiplies. It becomes an invisible trap hidden inside every mission plan. This is the rocket equation. It sounds like mathematics, but for Mars, it becomes something almost existential. Because the return home is not a single act, it is not simply pressing a button and watching a spacecraft lift from the red surface. To come back from Mars, humans first have to launch off Mars. Then they have to reach orbit. Then they have to leave Mars orbit. Then they must travel across interplanetary space. Then they must survive arrival at Earth. Each step demands energy. Each step demands mass. Each step demands fuel. And all of that fuel has to come from somewhere. On the Moon, the problem was difficult but manageable. The Moon is small. Its gravity is weak. It has no atmosphere to push through during launch. Apollo astronauts could leave the lunar surface in a relatively small ascent vehicle, rise into lunar orbit, dock with the command module, and begin the return to Earth. The Moon allowed a fragile kind of simplicity. Mars does not. Mars has more gravity, not Earth gravity, but enough to matter. Enough that lifting a crew, equipment, life support, and a return vehicle off the surface becomes a much heavier demand. Mars also has an atmosphere thin, but still present, which complicates landing, heating, dust, aerodynamics, and ascent design in ways the Moon never did. Mars is not strong enough to feel like Earth, but it is strong enough to punish you for underestimating it. That is the nightmare. The red planet is not massive like our home world, but it is massive enough that leaving it requires a serious rocket, and that rocket cannot magically appear on the surface. It must be sent there, assembled there, fueled there, protected there, and kept ready through dust storms, freezing nights, radiation, mechanical wear, and the long wait for the return window. In other words, the return mission has to be built before the crew can escape. That changes the emotional meaning of every kilogram. A kilogram of food is survival. A kilogram of shielding is protection. A kilogram of spare parts is resilience. A kilogram of science equipment is discovery. But a kilogram of return fuel is something different. It is hope. It is the physical weight of going home. And Mars needs a terrifying amount of it. If you try to bring that return fuel from Earth, the problem becomes almost absurd. You have to launch the fuel from Earth, which requires fuel. Then carry it across space, which requires more fuel. Then land it on Mars safely, which requires more systems, more shielding, more structure, more mass. Then store it for months or years. Then finally use it to lift humans off the surface and begin the journey back. A return ticket to Earth becomes a mountain of propellant moved across the solar system. Not for exploration, not for comfort, just to undo the journey. This is why Mars mission plans become so enormous when return is included. The spacecraft grows, the number of launches grows, the cost grows, the risk grows. Every attempt to make the mission safer makes it heavier. Every attempt to make it heavier demands more propulsion. The mathematics does not care that humans miss Earth. It only counts mass, velocity, and energy. This is where the dream of Mars begins to split in two. One path says, bring them back. And that path becomes larger, heavier, more expensive, more fragile. The other path says, do not design the first mission around return. Design it around staying. That thought feels dark at first. It feels like surrender. But to mission planners, it may begin to look like logic. If you do not need to lift the entire crew back to Earth, the mission changes. The spacecraft can be simpler, the mass can be lower, supplies can be sent ahead, habitats can be built for long-term survival instead of temporary shelter. Equipment can be delivered over multiple launch windows. The goal becomes not visit Mars and leave, but survive Mars and grow. The difference is enormous. A round-trip mission has to carry the burden of its own reversal. A settlement mission does not. But before we accept that conclusion, there is one elegant idea that seems to rescue the dream of return. What if we do not bring all the fuel? What if Mars itself provides part of the answer? This is one of the most powerful ideas in modern Mars planning. Use local resources. Do not treat Mars as merely a dead destination where everything must be imported. Treat it as a harsh world with materials that can be transformed. Carbon dioxide in the atmosphere, ice in the ground, energy from sunlight or nuclear power. Chemistry that might allow humans to make oxygen, water, or even rocket propellant on the surface. It is a beautiful idea, almost poetic. The planet that traps you might also contain the ingredients of your escape. But beauty is not the same as reliability, because making fuel on Mars does not remove the danger, it changes the shape of it. Instead of carrying the return fuel from Earth, you now depend on machines already waiting on Mars, machines that must land before humans arrive. Machines that must unfold, power themselves, collect resources, process gases, extract water or hydrogen, produce oxygen or methane, store everything safely, and keep doing this for months or years without repair crews standing beside them. The return ticket is no longer inside the rocket. It is inside a factory. A lonely factory sitting on a frozen desert world before the astronauts have even launched. And if that factory works, Mars becomes more possible. If it fails, Mars becomes a prison. That is the terrifying balance behind the return fuel nightmare. There may be a way home, but that way home is not simple, cheap, or guaranteed. It must be manufactured through physics, chemistry, machinery, timing, and luck. And every part of that chain has to hold. Because on Mars, running out of fuel is not like missing a flight. It means the sky is open. Earth is somewhere out there. The return window has come, and the crew still cannot leave. In the next part, we move into that fragile hope. The machines that may have to save the astronauts before they ever arrive, the promise of making oxygen and fuel from Mars itself, and the terrifying truth that a small success in a laboratory or even on a rover is not the same as trusting an entire human return mission to an automated factory on another planet. There is one idea that makes Mars feel less impossible. It is simple enough to sound obvious. Do not bring everything from Earth. Use Mars. Use the atmosphere. Use the ice. Use the sunlight. Use the dust, the minerals, the carbon dioxide, the cold local materials waiting on the surface. In space exploration, this idea is called In Situ Resource Utilization, ISRU. The phrase sounds technical, but the meaning is almost ancient. live off the land. Except this land is Mars. And Mars does not give easily. On Earth, living off the land means finding water, food, shelter, wood, stone, animals, plants, soil, rivers, weather, ecosystems. It means entering a world already full of systems that life can use. On Mars, there is no forest to cut, no river to follow, no animal to hunt, no breathable air, no fertile soil in the human sense, no soft environment waiting to help. To live off Mars, humans will have to force usefulness out of a hostile planet. They will have to turn carbon dioxide into oxygen, ice into water, water into hydrogen and oxygen, dust into building material, sunlight or nuclear power into the energy that keeps everything alive. And if the dream is not only to survive, but to return, then Mars must provide something even more precious. Propellant. That is the real promise of ISRO. Not just air for the habitat, not just water for drinking, but the possibility that a return vehicle could be fueled by materials processed on Mars itself, instead of hauling every kilogram of return fuel across tens of millions of miles from Earth. In theory, this changes everything. A crew would not need to arrive carrying the full weight of their escape. Machines could be sent first. They could land before the astronauts, begin working, gather local resources, produce oxygen, perhaps help manufacture rocket propellant, and slowly build the physical possibility of return. It sounds elegant. It sounds almost like the planet itself becomes part of the mission. But here's the problem. The machines have to work before humans ever bet their lives on them. That is where the hope becomes frightening. Because the return home may depend on a factory sitting alone on Mars, years before the crew arrives. No technicians beside it, no warehouse of spare parts, no warm repair bay, no human hands to listen for a strange vibration, tighten a seal, replace a valve, clear dust from a filter, or notice that something is slowly going wrong. Just a machine on a red planet, waiting, working, or failing quietly. We have already taken the first real step toward this future. NASA's MOXIE experiment, carried aboard the Perseverance rover, was designed as a technology demonstration to produce oxygen from Mars's carbon dioxide-rich atmosphere. NASA describes it as a critical first step toward sustained human presence on another planetary body. That matters. For the first time, a machine on Mars showed that oxygen could be extracted from the planet's own air, not imagined in a study, not only tested in a laboratory, done on Mars, in real Martian conditions. A small box inside a rover breathed in a fragment of the thin Martian atmosphere and separated oxygen from carbon dioxide. That is extraordinary. It is one of those quiet moments in exploration that does not look as dramatic as a launch or landing, but may matter just as much, because a future Mars mission will not survive by carrying Earth with it forever. It will survive by learning how to make Mars useful. But MOXIE was a demonstration, a beginning, not a return system. That distinction is everything. A small experimental device producing oxygen is not the same as an industrial-scale system capable of supporting a crew, filling large tanks, operating reliably for years, and generating enough oxidizer or fuel-related resources for a rocket to leave Mars. According to NASA's reporting, MOXIE completed its technical objectives and operated under different Martian conditions, but future human missions would need a far larger system. And scaling is never just making something bigger. Scaling means new failure modes, more heat, more power, more moving parts, more plumbing, more storage tanks, more dust exposure, more seals, more compressors, More electronics. More ways for the machine to betray the people depending on it. A small experiment can succeed and still leave the real nightmare unsolved. Imagine the mission plan. Years before the crew launches, cargo ships arrive on Mars. Not one, but several. They carry habitat modules, power systems, drilling equipment, reactors or solar arrays, spare parts, life support machinery, and the fuel production system that may determine whether the crew ever sees Earth again. These machines land separately across a world where landing itself is dangerous. They unfold. They check themselves. They connect to power. They begin testing valves, compressors, pumps, filters, heaters, tanks, chemical reactors. They search for accessible water or process the atmosphere. They begin producing what future astronauts will need. And back on Earth, mission controllers watch the data, day after day, month after month. A pressure reading, a temperature curve, a tank level, a power fluctuation, a dust warning, a compressor vibration, a number that looks slightly wrong. Somewhere on Mars, the return ticket is being manufactured molecule by molecule. But it is not enough for the machine to work once. It has to keep working. Through cold nights, through dust, through thermal expansion and contraction, through radiation, through software glitches, through mechanical wear, through months of isolation before any human can touch it. And if something critical fails, that is the question no one can avoid. If the system fails before launch, perhaps the crew never leaves Earth. The mission is delayed. A repair mission is planned. Engineers rebuild. Politicians argue. Budgets shift. The dream waits. But if the crew is already on Mars when the system fails, the word delay changes meaning. Delay becomes danger. Danger becomes confinement. Confinement becomes a race against food, oxygen, power, health, and time. This is why a Mars return mission may require proof before departure, not hope, not projections, not it should work. The return resources must already exist, or at least enough of them must be produced and verified before human lives are committed. Because Mars does not forgive optimism. That may be one of the great emotional reversals of human spaceflight. We usually imagine the rocket as the heroic machine, the tower of fire that carries humans upward. But on Mars, the most important machine may be the quiet one, the one sitting in dust long before the astronauts arrive, the one that no one applauds, the one that does not carry people but decides whether people can leave. A fuel plant may become more important than the flag, a compressor more important than the speech, a storage tank more important than the first footprint. That is the real shape of Mars exploration. Not one glorious landing, but a chain of working systems so long and fragile that a single weak point can change the mission's meaning. And this is where the one-way logic begins to return. If the machines needed for return are too heavy, too complex, too expensive, or too uncertain, then the mission planners face a brutal question. Should the first Mars missions be designed around coming home, or around not needing to? A settlement does not remove danger. In many ways, it increases it, but it changes the goal. Instead of building a temporary outpost around a return deadline, you build infrastructure meant to grow. You send spare parts not just for one mission, but for decades. You build habitats meant to expand. You build systems that support continuity, not escape. And that is why ISRU is both hopeful and haunting. If it works, Mars becomes a little less impossible. If it fails, Mars becomes much more honest. Because then we have to admit something uncomfortable. Perhaps the first humans on Mars will not depend on local resources to return home. They will depend on local resources to survive staying there. A machine that makes oxygen from Martian air is not only a tool, it is a prophecy. It says that humans may one day stop treating Mars as a place to visit and begin treating it as a place where Earth systems must be rebuilt from scratch. Air made by machine, water mined or recycled, food grown under glass, heat produced artificially, safety engineered every second, and home no longer given by a planet but manufactured by human persistence. So when we imagine the first astronauts arriving on Mars, we should not imagine them stepping into an empty wilderness. We should imagine them approaching a question already waiting for them. Are the machines still alive? Are the tanks full? Is the habitat sealed? Is there enough power? Is there enough oxygen? Is there still a way home? Or has Mars already made the choice for them? In the next part, the danger moves even closer. Because even if the machines work, even if the oxygen flows and the fuel tanks fill, even if the return vehicle stands ready on the surface, there is another system that must survive the journey: the human body. And after months in deep space, years in partial gravity, and constant exposure to radiation, the astronauts may discover that the hardest thing to bring back from Mars is not fuel. It is themselves. Even if the machines work, even if the fuel tanks fill, even if the oxygen flows through the habitat walls and the return vehicle waits patiently on the surface, there is still one system no engineer can fully replace: the human body. And that may be the most fragile machine of all. Because the body is not designed for Mars. It is not designed for deep space. It is not designed for months without Earth gravity, years under a weaker pull, constant radiation exposure, recycled air, confinement, stress, dust, and the knowledge that every biological problem is happening far beyond rescue. The body was built by Earth. Every bone, every heartbeat, every balance signal in the inner ear, every immune response, every muscle in the legs and back, every fluid shift inside the skull, all of it grew out of one planet's conditions: one gravity, one atmosphere, one magnetic shield, one pressure, one rhythm of day and night. One living environment that wrapped around human evolution for millions of years. We think of ourselves as independent beings, but biologically, we are Earth-shaped. Take that body away from Earth long enough, and it begins to change. At first, the changes are quiet, not cinematic, not dramatic, no alarms, no sudden moment where the body announces that it is becoming less earthly. It simply responds to its new environment. In microgravity, bones no longer carry weight in the same way. Muscles no longer fight constantly against the pull of the planet. The heart no longer has to pump blood upward against gravity with the same demand. Fluids shift. Pressure patterns change. The body starts making decisions that make sense in space, but may become dangerous when the person returns to Earth. NASA studies bone and muscle loss in microgravity because these changes are directly relevant to longer missions, including future journeys to Mars. Space station research is used to understand how to protect crews during multi-year exploration missions, but the challenge remains serious. That should make us pause, because the International Space Station is still close to Earth. Astronauts there are in orbit, supported by constant communication, resupply missions, medical monitoring, and the possibility of coming home relatively quickly compared with Mars. And even there, the body changes. Astronauts exercise intensely to slow muscle and bone loss. They follow strict routines. They are monitored carefully. Mars takes that problem and stretches it across a much longer, lonelier timeline. A crew going to Mars may spend months in microgravity during the outward journey. Then they arrive on a planet with only a fraction of Earth's gravity. Mars' gravity is not zero, and that matters. But we do not yet know whether it is enough to preserve the human body over years. That uncertainty is haunting. Because Mars' gravity feels like a compromise, but biology may not accept compromise. Maybe it is enough to slow the damage. Maybe it is enough for some systems, but not others. Maybe bones still weaken. Maybe muscles still decline. Maybe the cardiovascular system adapts to the lower demand. Maybe the body quietly begins to belong less to Earth. No human has lived for years in Martian gravity. We are guessing from pieces: Earth gravity, microgravity, short missions, long missions in orbit, bed rest studies, animal experiments, models, and caution. But Mars itself remains untested in the one way that matters most. No human body has grown old there. No human body has recovered from years there. No human body has tried to return from it. That is the frightening part. A return mission is not only a rocket question, it is a medical question. Could a person spend months traveling to Mars, years living in reduced gravity, months traveling back, and then survive the violence of re-entering Earth's world? Earth does not welcome returning astronauts gently. Earth has gravity, full gravity. The gravity that shaped us, yes, but also the gravity a weakened body must suddenly bear again. A returning crew must endure acceleration, landing forces, balance disruption, cardiovascular stress, and then the daily weight of standing, walking, breathing, sleeping, and moving under conditions their bodies may no longer be prepared for. Imagine that. You survive the launch. You survive deep space. You survive Mars. You survive the return journey. And then the planet you came from becomes the final test. Home becomes heavy. That may be one of the darkest possibilities of Mars travel, that an astronaut could come back to Earth and discover that Earth is no longer simple for them. The floor itself becomes resistance. Standing becomes work. A staircase becomes a mountain. Their own skeleton becomes uncertain. Their heart must relearn a world it once knew without effort. And then there is radiation. Radiation is different from gravity because you do not feel it working. There is no sound, no taste, no pressure on the skin, no visible warning. It passes through the body as invisible damage and probability. Beyond Earth's protective environment, astronauts face space radiation from sources such as galactic cosmic rays and solar particle events, and NASA treats radiation as one of the major hazards for human exploration beyond low Earth orbit. Mars crews would leave behind much of what protects us here. Earth's atmosphere and magnetic field are not decorative features. They are shields. They stand between biology and the charged particles moving through space. On Mars, the atmosphere is thin and there is no Earth-like global magnetic shield. A habitat can be protected. A spacecraft can be designed with shielding. Storm shelters can be built. But shielding adds mass, and mass returns us to the same old enemy: fuel. To protect the body better, the mission becomes heavier. To make the mission lighter, the body accepts more risk. Again and again, Mars forces trade-offs that feel almost cruel. Radiation can raise long-term cancer risk. It can affect tissues. It may interact with other stresses in ways we still do not fully understand. The National Academies has highlighted the uncertainties around managing long-term radiation risks for crewed missions beyond low Earth orbit. That word, uncertainty, matters. Because uncertainty is not safety. It means there are things we do not know because no one has ever lived through the full experiment. No human has spent years traveling to Mars, living on Mars, and returning from Mars. The first crew would not simply be passengers in a mission. They would be the data. Their bones, eyes, blood, nerves, immune systems, sleep cycles, moods, and aging cells would become part of humanity's first real test of whether Earth life can endure another planet long enough to come home. That is an uncomfortable truth. Every Mars astronaut would be a scientist, and also the experiment. The body may adapt in ways that help survival on Mars, but complicate return to Earth. It may become more efficient in lower gravity. It may conserve resources differently. It may lose what Earth once demanded. And if the mission lasts long enough, the boundary between temporary adaptation and permanent change becomes harder to define. This is where the phrase, "never come back," takes on a deeper meaning. Maybe they cannot come back because of fuel. Maybe because of cost. Maybe because the return window closes. Maybe because the machines fail. But maybe the most intimate reason is that Mars changes the traveler. Not spiritually, not metaphorically, physically. A body that leaves Earth may not be the same body that tries to return. And if humans are born there one day, the question becomes even stranger. A child growing under Martian gravity would not be an Earth body temporarily away from home. That child's bones, muscles, heart, and sense of balance would develop inside another world's pull. Earth would not be a place they left. It would be a place their body never learned. For them, returning to Earth might not mean going home. It might mean entering a gravity well too strong for the life Mars built. That is the deeper biological horizon of colonization. Mars would not just create a new address for humanity. Over time, it could create a new human condition people who share our ancestry, our language, our stories, but whose bodies belong more easily to red dust than blue oceans. And so, the terror of Mars is not only that it is far away, it is that distance gives the body time to change. The spacecraft might remain functional. The habitat might remain sealed. The machines might keep breathing for the crew. But somewhere quietly, cell by cell, bone by bone, heartbeat by heartbeat, Earth may be loosening its hold. In the next part, we move from the body to the world around it, or rather, the lack of one. Because on Mars, survival is not supported by nature, it is manufactured by systems. And when those systems fail, there is no ambulance, no rescue ship, no warehouse, no emergency flight from Earth. Only the crew. Only the habitat. Only whatever tools are already there. And the terrifying truth that no one is coming in time. On Earth, danger is almost never truly alone. If a fire starts, someone can come. If a person collapses, an ambulance can arrive. If a machine breaks, a technician can be called. If food runs out, more can be delivered. If water stops flowing, another system, somewhere in the larger civilization, can usually replace it. We live inside layers of rescue so familiar that we barely notice them. Hospitals, roads, aircraft, power grids, supply chains, emergency services, neighbors, warehouses, factories, other people. Even when we feel isolated, Earth is full of backup. Mars is not. That may be one of the hardest truths to feel honestly. A Mars habitat would not be a house in a dangerous place. It would be a tiny island of life, surrounded by an entire planet that cannot support a human body for even a moment without technology. There is no air outside, not breathable air. There is no lake to walk to, no field to harvest, no forest to shelter in, no village over the hill, no helicopter coming through the sky, no truck carrying spare parts up the road. There is only the habitat, a sealed structure full of machines pretending, with extraordinary effort, to be Earth. Inside, air must be cleaned and recirculated. Carbon dioxide must be removed. Oxygen must be supplied or generated. Humidity must be controlled. Water must be filtered, reclaimed, stored, and reused. Waste must be processed. Food must be preserved or grown. Temperature must be held within a survivable range, while the world outside swings between cold, dust, radiation, and silence. On Earth, these things are background. On Mars, they are the entire mission. Every breath is engineering. That single thought changes the feeling of survival. Breathing becomes not a natural right, but a system status. Water is not something that falls from clouds or moves through rivers. It is an inventory. Heat is not something the planet gives you. It is power converted into protection. Food is not a market or a harvest under open sky. It is calories counted against time. A Mars crew will live inside a place where the difference between normal life and emergency may be one failing pump, one valve that sticks, one cracked seal, one clogged filter, one software fault, one dust-covered solar array, one medical problem no one planned for. This is why Mars is different from every human frontier before it. When people crossed oceans, the journey was deadly, but the destination was still Earth. Air was waiting on the other side. Gravity was familiar. Water existed somewhere. Plants could grow under the open sky. Animals moved across land and sea. Even the harshest places on Earth remain part of a living planet. Mars gives no such mercy. A person cannot simplify life there. They cannot return to basic survival if technology fails. There is no version of living off the land that looks like hunting, gathering, camping, farming by hand, or building a wooden shelter. The land is not dead in a poetic sense. It is functionally unavailable to biology without machines. If the machines fail, survival collapses quickly. And because Earth is so far away, failure cannot be answered in time. This is where the word rescue begins to lose its meaning. On the International Space Station, danger is real, but Earth is close. The station is supported by regular cargo flights, ground teams, constant monitoring, and return spacecraft. If a system fails, engineers on Earth can analyze the problem in real time. If supplies are needed, they can be launched. If evacuation becomes necessary, the crew can come home. The ISS is not independent from Earth. It is Earth's highest outpost. Mars would not be that. A message from Mars takes minutes to reach Earth, depending on where the planets are. A reply takes minutes to return. That delay may not sound large in ordinary conversation, but in an emergency, it becomes enormous. If pressure is dropping, if smoke appears, if a crew member is injured, if a life support alarm sounds, the astronauts cannot wait for a calm answer from mission control. By the time Earth understands the emergency, the crew may already have solved it, or failed to. So Mars crews must become more than astronauts. They must become their own engineers, doctors, mechanics, farmers, mission controllers, and emergency responders. Every critical skill must exist inside the habitat, because outside help is not outside the door. It is millions of miles away. And even if Earth prepares a response immediately, physical help cannot arrive quickly. A resupply mission would need to be built, launched during an available window, and then travel for months. In many cases, the crew would be dead long before the solution reached them. This is not pessimism. It is distance. Distance turns every crisis inward. That is what makes Mars psychologically brutal. The crew will know that every emergency belongs first to them. They can send data, ask for advice, receive instructions, and be supported emotionally from Earth. But the action must happen on Mars. Human hands inside the habitat must make the repair. Human judgment inside the habitat must decide the risk. Human calm inside the habitat must keep fear from spreading faster than the problem. And the systems are not simple. Life support is one of the most complex forms of engineering because it must imitate a planet. A habitat has to maintain air chemistry, pressure, temperature, humidity, water recovery, waste processing, and contamination control. It has to do this not once, not during a demonstration, but continuously, day after day, month after month, year after year. There are no weekends for life support. No pauses. No, we'll fix it tomorrow if the failure affects breathing. Food adds another layer of vulnerability. At first, Mars crews would likely rely heavily on stored food, but for long-term presence, growing food becomes essential. That means pressurized growing areas, power for lighting, water recovery, nutrients, temperature control, disease prevention, and enough biological redundancy to survive crop failures. A greenhouse on Mars is not a garden. It is a life support machine with leaves. And if crops fail, the problem is not disappointment, it is mathematics. Calories remaining, days remaining, people remaining, and medicine becomes just as frightening. On Earth, a health problem is surrounded by hospitals and specialists. On Mars, even a minor issue can become serious if supplies are limited. A tooth infection, a broken bone, appendicitis, a severe allergic reaction, a psychological crisis. Every medical event must be handled with whatever equipment, medication, training, and improvisation the crew has available. The body cannot be shipped home for treatment. The doctor, if there is one, is also trapped. Even spare parts become a form of life. A filter is not just a filter. A pump is not just a pump. A gasket is not just a gasket. A circuit board is not just a circuit board. On Mars, each object carries a piece of the future. Use it, and it wears down. Break it, and it may not be replaceable. Repair it badly, and another system may fail later. The colony would have to treat maintenance almost like a religion, because survival would depend on keeping thousands of ordinary parts from becoming extraordinary disasters. This is where the mission begins to look less like exploration and more like a tiny civilization under pressure. Exploration can tolerate temporary discomfort if return is near. Settlement cannot. Settlement means building systems that continue. It means redundancy, repair culture, manufacturing, training, food production, power stability, social trust, medical capability, and enough people with enough skills to prevent one failure from becoming final. A Mars base cannot be merely visited into existence. It has to be sustained into existence. And that realization changes the meaning of the first crew. They would not simply collect rocks or deploy instruments. They would be the beginning of a support system that must eventually support others. Every repair they make, every procedure they write, every habit they form, every problem they solve becomes part of the future culture of Mars. If they survive, it will not be because Mars became kind. It will be because they learned to build kindness into machines. Air that keeps returning, water that keeps cycling, heat that keeps holding, food that keeps growing, people who keep trusting each other when there is nowhere else to go. But this also brings us closer to the darkest logic of the mission. If survival on Mars already requires habitats, power systems, food systems, repair systems, medical systems, and local resource use, if the crew must stay for long periods anyway, if rescue is not realistic, if return requires even more mass, more fuel, more risk, and more cost, then the question changes. Why design the first Mars missions around leaving? Why not design them around staying? In the next part, we face that uncomfortable possibility directly. The idea that sounds cruel at first, a one-way mission may become, under the pressure of physics and economics, the most practical path. Not because it is emotionally easy, not because it is morally simple, but because Mars may force humanity to choose between a symbolic visit and a permanent beginning. At some point, the question becomes uncomfortable, not because Mars is impossible, but because the most practical version of Mars may not look like the dream we were promised. For decades, we have imagined the first human mission to Mars as a triumph of return. A crew launches from Earth, crosses deep space, lands on the red planet, plants instruments in the dust, gathers samples, speaks a few historic words, and then comes home. That is the story we understand. A journey with closure. A danger survived. A door opened and then safely closed again. But Mars resists that shape. The deeper you follow the mission, the more the return begins to look like the heaviest part of the entire dream. Returning requires fuel. Fuel requires mass. Mass requires more launches, more money, more systems, more risk. Returning requires a functioning ascent vehicle, a working fuel supply, a correct launch window, a healthy crew, a survivable spacecraft, and Earth re-entry after years of biological stress. Every return plan carries the weight of escaping Mars. And that weight changes everything. Because if the crew does not need to return, the mission becomes radically different. Not easy, never easy, but different. A one-way mission does not need to lift the same burden back off the Martian surface. It does not need to design every system around reversal. It can send equipment ahead. It can build slowly. It can focus on habitat expansion, life support, food production, power, radiation shielding, repair tools, medical supplies, and local resource use. The goal changes from coming home to making home. That phrase sounds simple, but it changes the entire architecture of the future. A round-trip mission is an expedition. It is temporary by design. Its success is measured by whether the crew survives, completes objectives, and returns safely to Earth. A settlement mission is not temporary. Its success is measured differently. Can the habitat keep working? Can the crew produce water, oxygen, food, and power? Can more people arrive later? Can the base expand? Can one mission become 2, then 5, then 20? Can Mars become not a destination, but a continuing human presence? This is where the dark logic begins. A round-trip mission may be emotionally easier to accept, but physically and economically harder to execute. A one-way mission may be emotionally devastating, but strategically more coherent. That is the contradiction at the heart of Mars. The humane story is return. The practical story may be permanence. And once you see that, the first humans on Mars begin to look less like astronauts and more like founders. Astronauts visit dangerous places on behalf of Earth. Founders leave one world to begin another. There is a moral discomfort in saying this aloud. A one-way mission feels harsh. It sounds like asking people to accept exile in exchange for history. It sounds like turning human beings into tools for a dream larger than themselves. And maybe that discomfort is necessary. It should not feel easy. To send someone to Mars, knowing they may never come back, would be one of the most serious choices any civilization has ever made. It would require consent so complete and so honest that no romance could be allowed to hide the truth. The crew would need to know exactly what they were choosing. Not a heroic vacation, not a longer Apollo, not a mission with guaranteed applause at the end. A life. A new life in a place that may always remain dangerous. The ethics of that choice are not simple. Some people would say no civilization has the right to send humans on a one-way journey when Earth still has poverty, disease, conflict, and suffering. Others would argue that if informed volunteers choose the risk, if they understand the permanence, if they believe the purpose matters enough, then denying them the chance would also be a kind of arrogance. Human history is filled with people who left home without knowing if they would ever return. But Mars is different. The old frontiers were still on Earth. They had air, they had gravity, they had ecosystems, even when hostile. A person could arrive with tools and learn to live from the land. Mars has no land in that sense. Mars has resources, but not mercy. A Mars settler cannot breathe the atmosphere, drink from streams, hunt animals, build a fire under open sky, or survive by instinct. The settlement must remain technological every second. Survival depends on machines, discipline, cooperation, and maintenance. So the decision to stay is not a romantic frontier myth. It is a contract with engineering. And yet, the case for staying grows stronger because Mars punishes the idea of temporary presence. If you must send habitats, power systems, oxygen systems, water recovery systems, food production experiments, medical supplies, radiation shielding, tools, rovers, and spare parts just to keep the crew alive, then much of what you are building already resembles the beginning of a base. Why build all of that only to abandon it? Why spend the enormous cost of reaching Mars, surviving the landing, deploying infrastructure, and adapting to the planet, only to tear the story short and focus everything on escape? That is the question Mars asks quietly. And it is not sentimental. It is logistical. A return mission proves that humans can visit Mars. A settlement proves that humans can continue there. Those are not the same achievement. The first is spectacular. The second is historic in a deeper sense. A visit creates a memory. A settlement creates a future. That is why the one-way logic feels so dark and so powerful at the same time. It takes the part of the mission that feels most tragic, never coming home, and turns it into the very thing that makes the mission meaningful. The first settlers would not be stranded if they chose permanence. They would be committed. But commitment does not erase grief. They would still leave behind rain, oceans, trees moving in the wind, cities glowing at night, family meals, open windows. The casual miracle of walking outside without calculating oxygen, pressure, radiation, and suit integrity. They would leave the planet that made them. And Mars would ask them to build, from machinery and discipline, a smaller version of what Earth once gave freely. Air inside walls, water inside tanks, food under lamps, warmth from power, community in confined rooms, hope in scheduled launches from a world millions of miles away. This is why a Mars settlement would not begin with domination. It would begin with dependence. The first colonists would depend on Earth for supplies, instructions, replacement parts, new crews, and emotional connection. Mars would not become independent quickly. It might take generations, perhaps centuries. At first, it would be less like a new nation and more like a fragile outpost, alive only because Earth keeps choosing to remember it. But even that would be enough to change humanity. Because the moment humans are living permanently on another planet, Earth is no longer the only place where our story can continue. That may be the deepest argument for staying. Not escape, not conquest, not abandoning Earth, but widening the definition of survival. A one-way Mars mission would force humanity to admit that becoming multiplanetary is not a clean, heroic leap. It is messy, painful, morally complex, expensive, dangerous, and full of unanswered questions. But perhaps every true threshold is like that. Perhaps the first people who go to Mars will not be remembered because they found a way back. Perhaps they will be remembered because they accepted that back was no longer the point. In the next part, we move into the inner world of that decision. Not the rockets, not the costs, not the mission architecture, but the human mind facing a permanent goodbye. Because the hardest thing to launch toward Mars may not be a spacecraft. It may be a person who understands they are leaving Earth forever. There is a kind of distance that cannot be measured in miles. Mars is millions of miles away, yes, but the deeper distance is not between planets. It is between one version of a human life and another. Because when someone leaves Earth for Mars, knowing they may never return, they are not simply changing location. They are crossing a psychological boundary that no human has ever crossed before. They are leaving the only world where human beings are naturally possible. Think about what that really means. Not as a headline, not as a mission graphic, not as a dramatic animation of a rocket leaving Earth, but as a life. The last morning before launch, the last time stepping outside without a pressure suit, the last time breathing air that was not filtered through a machine, the last time feeling rain touch skin, the last time hearing wind move through trees, the last time standing near an ocean and knowing it is not behind glass, not in a memory, not stored as a video file. For most astronauts, leaving Earth has always carried the promise of return. They could look at the planet from orbit or from the moon and know that home was still waiting. Their mission had an end. Their absence had a shape. They were visitors to danger, not permanent citizens of it. But a Mars settler may not have that psychological shelter. There may be no countdown to coming home, only a countdown to departure. That changes everything. Because the human mind is not built only from thoughts. It is built from places, familiar streets, voices in nearby rooms, the smell of food, the weight of gravity, the color of the sky, the ordinary comfort of knowing that if you walk far enough, you are still somewhere on Earth. Mars takes that away. Not suddenly, perhaps. At first, the crew would be consumed by tasks, checklists, systems, training, launch procedures, transit schedules, technical problems. The mind stays busy when survival is complicated, but eventually the emotional truth would arrive. Maybe during the long journey, when Earth has already shrunk into a star-like point behind them. Maybe after landing, when the first excitement fades and the habitat becomes routine. Maybe during a message from home, delayed by minutes, where a parent, a child, a friend, or a partner speaks from a world the astronaut can no longer touch. That is when Mars becomes real. Not as achievement, as separation. A person on Mars would still be able to see Earth in images. They could receive videos, recordings, news, music, birthdays, messages. They could watch oceans from orbiting satellites, hear rainfall through headphones, see forests filmed by drones, follow the lives of people they love. But none of it would be immediate. None of it would be reachable. Communication delay changes emotion in a way that is difficult to explain. A conversation becomes correspondence. Comfort becomes asynchronous. If someone on Mars is afraid, lonely, angry, or grieving, they cannot call home and hear a voice answer instantly. They can send a message into space and wait. That wait becomes part of the loneliness. On Earth, when we miss someone, we can imagine crossing a distance, a car ride, a flight, a train, a road. Even if we cannot go immediately, the possibility remains inside the mind. For a Mars settler, that possibility may be gone. The mind has to learn a new category of loss, a living world that still exists but cannot be returned to. This is why permanent Mars settlement would require more than courage. It would require a strange kind of grief management. The first settlers would have to mourn Earth without losing the will to live on Mars. They would have to remember home without being destroyed by it. They would have to let Earth remain meaningful while accepting that Mars is now the place where mourning happens. That is not simple adaptation. That is identity reconstruction. Who are you when the sky above you is no longer the sky you were born under? Who are you when every childhood memory belongs to a planet your body may never touch again? Who are you when home becomes not a location, but a past life? Some people may be able to make that transition. Humans are deeply adaptable. We have lived in deserts, ice fields, mountains, islands, submarines, space stations, and war zones. We form routines. We create meaning. We attach ourselves to new landscapes, new groups, new rituals. But Mars would test adaptation in a way no environment on Earth can. Because on Earth, even isolation has an outside world that supports life. On Mars, outside is not freedom. Outside is danger. The habitat would become the psychological universe. The crew would eat, sleep, work, argue, repair, recover, celebrate, and grieve inside confined spaces where privacy is limited and every relationship matters. A small irritation could grow in the silence. A personality clash could become a mission risk. A bad mood could spread through the only community available. There is no leaving the group. No moving to another city. No taking a weekend away. No walking into a forest alone to calm down. Even solitude would be scheduled, engineered, and limited by walls. This is where the human element becomes as important as the technical one. A Mars crew would not survive on intelligence alone. They would need patience, emotional discipline, forgiveness, humor, trust, the ability to repair relationships the way they repair machines, because on Mars, a broken relationship can become part of the life support problem. Every person becomes infrastructure. The engineer who fixes the oxygen system is infrastructure. The medic who treats an injury is infrastructure. The botanist who saves a crop is infrastructure. The calm person who prevents panic from spreading is infrastructure. And the crew must know this about one another. They must know that survival depends not only on skill, but on remaining human under pressure. Then there is the most frightening psychological question of all. What happens if someone regrets going? Not before launch, not during training, not when there is still time to step away, but after landing, after the return path has become uncertain or impossible, after Earth is only a delayed signal, after the person realizes that the dream they volunteered for has become smaller, colder, harder, and lonelier than they imagined. What do you say to someone who wants to go home when home is no longer available? There may be no answer gentle enough. You can support them. You can listen. You can treat depression, fear, panic, and grief as real medical conditions. You can build a culture that allows pain to be spoken instead of hidden. But you cannot open the door to Earth. That is the psychological edge of Mars. The mission asks people to choose permanence before they can truly know what permanence feels like. And perhaps that is why the first settlers will have to be selected not only for bravery, but for a relationship with loss. They must be people who can carry memory without being consumed by it. People who can love Earth and still build on Mars. People who can accept that their sacrifice is not a single heroic moment, but a daily practice. Waking up under red skies, checking pressure seals, recycling water, reading old messages, maintaining machines, planting food, watching Earth as a point of light, choosing again and again not to collapse under the meaning of what they left behind. The first Martians may not be the people who fear nothing. They may be the people who feel the loss most clearly and go anyway, because they understand that Mars is not asking for a visit. It is asking for a life. In the next part, we move from the private mind of the settler to the kind of person Mars itself will demand, not the astronaut as we know them, but a new human role entirely. Builder, repairer, farmer, doctor, engineer, mediator, and pioneer, all trapped inside one fragile settlement where every relationship becomes part of survival. The first people on Mars may wear spacesuits. They may arrive in spacecraft. They may train like astronauts, speak with mission control, follow procedures, run experiments, collect samples, and carry the symbols of Earth with them into the red dust. But if they stay, they will stop being astronauts in the old sense. Astronauts visit. Martians remain. That difference may sound small at first, but it changes everything. An astronaut is part of a mission. A colonist is part of a future. An astronaut survives a dangerous environment for a limited time, then returns to the world that supports them. A Martian settler must help build the support system itself. They cannot simply depend on Earth's civilization. They must begin recreating tiny pieces of it inside pressure walls, under radiation shielding, beside machines that cannot fail. That means the first Martians will need to be a different kind of human. Not just brave, not just intelligent, not just physically strong. They will need to be useful in many directions at once. On Earth, modern civilization allows people to specialize. One person becomes a surgeon, another becomes a farmer, another repairs engines, another writes software, another studies geology, another handles water systems, electrical systems, law, psychology, education, construction, cooking, communication, logistics, conflict resolution. On Mars, for a long time, there will not be enough people for narrow specialization. The doctor may need to repair a pump. The engineer may need to help grow food. The botanist may need to assist in a medical emergency. The commander may need to clean filters. The mechanic may need to understand software. The person who keeps morale alive may become as important as the person who keeps the oxygen flowing. Mars will not reward ego. Mars will reward usefulness. A small settlement cannot afford people who only know one thing. It cannot afford people who fall apart when plans change. It cannot afford people who need comfort more than purpose. It cannot afford people who cannot forgive. It cannot afford people who treat ordinary maintenance as beneath them. Because on Mars, ordinary maintenance is survival. A loose seal is not an inconvenience. A strange sound in a compressor is not background noise. A failed crop is not a bad season. A personal conflict is not just drama. Everything connects to the continued existence of the settlement. That is what makes Mars so different from the romantic idea of exploration. The great danger may not always be dramatic. It may not be the meteor strike, the explosive decompression, the dust storm swallowing the horizon, or the terrifying landing sequence. It may be smaller: a worn valve, a cracked hose, a tired crew member making a careless mistake, a disagreement that becomes resentment, a hidden injury, a sick plant, a missing spare part, a software error no one understands, a person who stops sleeping, a person who stops speaking. On Earth, small problems are absorbed by the vastness of civilization. On Mars, small problems have nowhere to go. They remain inside the habitat until someone solves them. This means the first Martians will live inside a culture of attention. They will listen to machines the way sailors once listened to the sea. They will know the normal hum of the air system, the normal rhythm of water recycling, the normal behavior of lights, heaters, pumps, vents, batteries, pressure doors, and growing chambers. They will notice when something feels slightly wrong, because slightly wrong can become fatal. That kind of life changes people. It makes care into a survival skill. It makes patience into infrastructure. It makes trust as important as oxygen. And trust may be the hardest system to engineer. Imagine a settlement of 6 or 8 people during the early years. The same faces every morning, the same voices in every emergency, the same habits, jokes, fears, weaknesses, and frustrations. No one is optional. No one can simply be removed from the group without creating a deeper crisis. If 2 people dislike each other, they still may have to repair a life support unit together. If someone makes a mistake, the others still have to sleep beside them, work beside them, depend on them. A Mars settlement will need emotional technology as much as physical technology. Not machines, but practices. Ways to resolve conflict before it becomes poison. Ways to apologize. Ways to rest. Ways to speak honestly without destroying morale. Ways to grieve when Earth feels too far away. Ways to remember that every person inside the habitat is trapped inside the same fragile miracle. Because the greatest threat to a small Mars colony may not be that humans are weak. It may be that humans are human. We get tired. We become afraid. We misunderstand each other. We carry private sadness. We grow irritated by small things. We need space. We need tenderness. We need meaning beyond survival. A settlement that forgets this will fail even if its machines work. So the first Martians may have to become something like a monastery, a ship crew, a research station, a hospital, a farm, a workshop, and a family all at once. Not family in the sentimental sense, but in the unavoidable sense. People bound together because leaving is not an option. They will celebrate strange milestones. The first full month without a major repair. The first successful harvest grown under artificial light. The first time a damaged system is rebuilt using only local materials. The first dust storm survived without losing power. The first birthday where everyone knows the person is 1 year farther from Earth, not closer to home. These moments may look small from outside, but inside the colony, they will become history. Because civilizations are not built only from great speeches and heroic landings. They are built from repeated acts of survival, meals prepared, wounds treated, filters replaced, data logged, seeds planted, arguments resolved, children taught, if children ever come, music played softly in a pressurized room while red dust moves beyond the window. Mars will require all of this. Not just science, culture, because people cannot live on oxygen alone. They need stories, rituals, humor, memory, beauty, something to remind them that they are not simply maintaining machines, but creating a human world, where none existed before. That may be the hidden work of the first Martians. They will not merely explore Mars. They will begin teaching Mars how to hold human meaning. And over time, if the settlement survives, their identity will shift. At first, they will still think of themselves as people from Earth living on Mars. Their accents, languages, food, jokes, fears, and dreams will all come from the blue planet behind them. But slowly, Mars will enter them. The schedule will follow Martian days. The seasons will become Martian seasons. The horizon will become familiar. The dust will become weather. The habitat will become neighborhood. The first greenhouse may become the first garden. The place that once felt like exile may begin to feel like belonging. And that is when the mission changes forever. Because the first Martians will not be defined by the fact that they left Earth. They will be defined by what they build after Earth becomes unreachable. In the next part, the story moves beyond the first crew. Because if Mars becomes permanent, then one day there may be humans who never left Earth at all because they were never born there. Children raised under red skies, in lower gravity, with Earth as an ancestral light in the night. And for them, the word return may no longer mean what it means to us. If the first humans on Mars survive long enough, the story will change. At first, Mars will be a mission. A dangerous mission. A historic mission. A mission watched by billions of people on Earth. Every step will be documented. Every repair will matter. Every meal, every medical problem, every dust storm, every communication delay will feel like part of one enormous experiment. But a mission is not the same as a world. A mission has an ending. A world does not. And if Mars becomes permanent, then eventually the focus will shift away from the first crew and towards something much stranger. The first generation born there. That is when Mars stops being only a destination. It becomes a birthplace. Try to imagine that child. Not an astronaut. Not a settler. Not someone who chose exile. Not someone who watched Earth shrink behind them through a spacecraft window. A child who opens their eyes for the first time inside a habitat on Mars. A child whose first sky is not blue, whose first horizon is red dust beyond glass, whose first understanding of outside is not grass, wind, birds, rain, or open air, but a place that requires pressure suits, airlocks, oxygen checks, radiation warnings, and adult supervision. For that child, Mars would not be an adventure. It would be normal. The hum of life support systems would be background noise. The recycled air would be ordinary air. The greenhouse would be their forest. The habitat corridors would be their streets. The red landscape beyond the windows would not feel alien in the same way it feels alien to us. It would be the world. And Earth? Earth would become something else. A place in stories. A place in old videos. A blue planet in lessons and family memories. The world of ancestors. Parents might describe oceans. Real oceans, not storage tanks. Water stretching beyond sight. Waves moving under an open sky. Salt wind, beaches, storms. Rain falling naturally from clouds. Not condensation captured and purified through machinery. They might describe forests. Trees taller than habitats. Leaves moving in air that no one had to manufacture. Soil full of organisms. Birds, insects, animals, smells, decay, growth. Life so abundant that humans on Earth often forget they are surrounded by it. They might describe walking outside. Just opening a door and stepping into the world. No suit. No pressure check. No oxygen calculation. No radiation monitor. No fear that a small tear in fabric means death. To a child born on Mars, that may sound impossible. Beautiful, maybe, but almost mythical. The way we might imagine standing beneath the oceans of Europa or walking through the methane rain of Titan, not impossible in theory, but beyond ordinary life. And that is the first emotional break between Earth humans and Martian humans. For us, Earth is home. For them, Earth may be origin. Those are not the same thing. The difference becomes even deeper when biology enters the story. A child growing up in Martian gravity would not simply be an Earth child living far away. Their body would develop under different physical demands. Their bones, muscles, heart, balance, movement, and sense of weight would all be shaped by the lower gravity around them. We do not know exactly what that would mean. That uncertainty matters. Maybe medicine and exercise could help. Maybe future habitats would include artificial gravity systems. Maybe children would spend time in rotating structures to strengthen their bodies. Maybe technology would find ways to preserve Earth-like physiology, even on Mars. But if children grew up mostly under Martian gravity, Earth might become physically difficult for them. Perhaps uncomfortable. Perhaps dangerous. Perhaps, for some, impossible. Imagine that reversal. For the first settlers, Mars is the harsh new world. For their descendants, Earth may become the world too heavy to enter. A planet where the air is abundant, the oceans are real, and the sky is blue but the gravity presses too hard. Stairs become exhausting. Standing becomes labor. The human body that Mars shaped may not easily belong to the planet where humanity began. In that future, returning to Earth no longer means coming home. It means visiting an ancestral gravity, a gravity their bodies never learned. That is one of the strangest possibilities in all of human expansion. Not that Mars will simply be far away, but that distance and biology may create a one-way bridge across generations. The first settlers may never return because the mission is too difficult. Their children may never return because Earth is no longer their world. And yet, they would still be human. They would speak human languages, at least at first. They would inherit Earth science, history, music, stories, mistakes, hopes, and warnings. They would know that somewhere in the night sky is a blue planet where rivers flow without pumps and forests grow without pressure walls. But knowledge is not belonging. A Martian child may know Earth the way we know ancient homelands we have never visited, real, important, emotionally powerful, but not the place that shaped our daily life. Their memories would be Martian. First steps in low gravity. First lessons about airlocks. First emergency drill. First time seeing Earth through a telescope. First crop failure. First dust storm. First story about the founders, the people who left Earth knowing they might never return, so that someone else could one day call Mars home without choosing exile. That is how settlement becomes civilization. Not when humans land. Not when a flag is planted. Not even when the first base survives its first year. Mars becomes a human world when children begin inheriting it instead of choosing it. And that thought is both magnificent and sad. Magnificent, because it means humanity has crossed a threshold older than civilization itself. We would no longer be a species of one world. Human life would have taken root somewhere else, however fragile, however dependent, however difficult. Sad because something would be lost in the crossing. A shared sense of Earth as the only home. For all of human history, every culture, every empire, every language, every conflict, every love story, every scientific discovery has happened under the same planetary condition. We have disagreed about almost everything, but we have all been Earth-born. all held by the same gravity, all breathing the same atmosphere, all living under the same sky, even when we gave it different names. Mars would change that. It would divide human experience at the most basic level. There would be people who remember rain from childhood, and people who only know rain from recordings. People who grew up under blue skies, and people who grew up under red ones. People whose bodies expect Earth, and people whose bodies belong to Mars. That is not just colonization. That is divergence. Slow at first, cultural before biological, emotional before evolutionary, but real. And maybe that is what becoming a multi-planet species truly means. Not simply building rockets, not simply landing on another world, not simply proving that humans can survive for a while inside machines. It means accepting that humanity may become plural. Different homes, different bodies, different memories, different meanings of the word normal. To us, Mars is the alien world. To future Martians, Earth may be the alien miracle heavy, blue, wet, overflowing with life, beautiful beyond belief, and perhaps impossible to live on. That is the deepest twist in the question of return. At first, we ask whether humans can come back from Mars. But if Mars becomes home, another question appears. Will they even want to? Or will Earth become what Mars is to us now, distant, luminous, unreachable, and filled with a beauty that belongs more to imagination than daily life? In the next part, all of these threads come together: distance, fuel, biology, radiation, cost, psychology, settlement, and future generations. Because the real reason people may never return from Mars is not one single obstacle. It is that Mars changes the meaning of return itself. By now, the question has changed. At the beginning, it sounded simple. Why would anyone who goes to Mars never come back? It sounded like one problem must be responsible, one missing technology, one dangerous flaw, one weakness in the mission plan. Something we could solve with a better rocket, a stronger habitat, a faster engine, a safer landing system. But Mars is not terrifying because of one obstacle. Mars is terrifying because every obstacle supports the next. Distance makes rescue impossible. Orbital mechanics controls the schedule. Fuel makes return expensive. Making fuel on Mars makes the mission dependent on machines already waiting there. Radiation damages the body quietly. Low gravity may change human physiology. Life support must replace an entire planet. Economics favors permanence over return. Psychology turns distance into grief. Future generations may not even belong to Earth in the same way we do. And when all of those truths are placed together, the conclusion becomes harder to avoid. The first humans on Mars may never return, not because humanity fails, but because Mars changes the mission. It turns exploration into settlement. That is the real reason. Not one explosion. Not one broken engine. Not one tragic mistake. A transformation. We keep imagining Mars as a place to visit because that is the pattern we inherited from the Moon. Apollo gave us a beautiful story. Leave Earth, touch another world, come back, transformed. But Mars may not allow that kind of closure. Mars may demand something deeper and more permanent. It may ask humans to stop thinking like visitors. A visitor designs around departure. A settler designs around continuity. A visitor asks, how do we get home? A settler asks, how do we make this place survivable tomorrow, and the day after that, and the year after that? Those questions build different worlds. A return mission is built around escape. A colony is built around endurance. And perhaps that is why the idea feels so unsettling, because it forces us to admit that humanity's next great step may not look like the heroic image we want. It may not be a crew returning to cheering crowds, carrying red dust and historic photographs. It may be quieter, harder, more painful. A few people leaving Earth forever. A habitat humming under a red sky. A greenhouse with fragile leaves growing under artificial light. A crew listening to delayed messages from a blue planet they can no longer touch. A life measured not by the date of return, but by whether the oxygen system is still working. That is not the Mars dream we were promised. But it may be the Mars dream that physics allows. This is where courage begins to change shape. The courage of Apollo was the courage to go somewhere dangerous and return. The courage of Mars may be the courage to go somewhere dangerous and remain. To accept that home is not waiting at the end of the mission. To trade the comfort of return for the possibility of beginning a second human world. That is a different kind of bravery. Less cinematic, perhaps, but maybe greater. Because it is not the bravery of a moment, it is the bravery of repetition, waking up again and again under an alien sky, checking systems again and again, repairing machines again and again, growing food again and again, managing fear, loneliness, conflict, illness, and fatigue, not for days, but for years. Mars will not be conquered by one landing. It will be survived by maintenance. That is humbling, because human beings like to imagine exploration as a story of triumph over nature. We climb the mountain, cross the ocean, reach the pole, land on the moon, plant the flag, prove that we can go where no one has gone before. But Mars does not care about flags. Mars will only care whether the habitat pressure holds, whether the crew can recycle enough water, whether the power system survives the dust, whether the plants grow, whether the people can keep trusting each other, whether Earth keeps sending supplies long enough for Mars to begin supporting itself. The red planet reduces ambition to systems. And systems either work or they don't. That is why the return question becomes almost secondary. If the first humans on Mars are truly trying to make humanity multiplanetary, then their purpose is not to come back with proof that Mars can be visited. Their purpose is to become the proof that Mars can be inhabited. Those are very different legacies. A visitor brings home a story. A settler becomes part of the story a future world tells about itself. One day, if Mars survives as a human place, future generations may not remember the first crew primarily as astronauts. They may remember them as the people who crossed the impossible threshold. The ones who accepted that the first step onto Mars was not the climax, but the beginning of a long and fragile struggle to make life continue where life had no right to continue. And those future Martians may understand the sacrifice better than we do. To us, never returning sounds like tragedy. To them, it may sound like origin. They may walk through pressurized corridors named after the founders. They may study the first landing site the way people on Earth study ancient settlements. They may listen to recordings of the first voices from Mars and hear not just history, but ancestry. They may look at Earth and feel gratitude, but not homesickness, because their home will be beneath their feet. That is the emotional turn Mars forces upon us. The thing that sounds like loss from Earth may become belonging from Mars. The person who never comes back may not be stranded if they are building the place where their descendants will belong. But that does not erase the cost. It only gives the cost meaning. The first settlers would still lose almost everything familiar. They would lose immediate closeness to family. They would lose oceans, forests, rain, wildlife, and open air. They would lose the casual safety of a planet that supports human life without being asked. They would lose the possibility of escaping into a larger world when life becomes too small. Mars would be smaller, at least at first. A few rooms, a few people, a few machines, a few crops, a few windows looking out onto a silent red desert. And yet, inside that smallness would be something enormous. The first continuation of humanity beyond Earth. That contradiction is what makes the subject so powerful. Mars is both claustrophobic and cosmic. It is a tiny habitat surrounded by an entire planet, a handful of humans separated from billions. A fragile machine holding life against a universe that has never promised to be livable. And maybe that is why Mars matters. Not because it is easy, because it reveals the truth of what we are. We are a species built by Earth, dreaming of places Earth never prepared us for. We are soft bodies trying to cross hard distances. We are emotional creatures trying to become interplanetary. We are animals of air, water, warmth, and gravity, imagining a future inside sealed rooms under alien skies. That future may be magnificent, but it will not be gentle. If humans go to Mars, the mission will not only test rockets, it will test whether a species can carry the idea of home into a place where home must be manufactured. It will test whether we can turn survival into culture, machinery into shelter, isolation into community, and sacrifice into continuity. This is why the answer cannot be reduced to a simple claim that return is impossible forever. Perhaps one day, faster propulsion will exist. Perhaps artificial gravity will protect the body. Perhaps radiation shielding will improve. Perhaps Mars will have enough infrastructure that travel between worlds becomes routine. Perhaps future humans will move between Earth and Mars the way we now cross oceans. But that is not the first chapter. The first chapter is harsher. The first chapter belongs to the people who go before the road exists. Before comfort. Before redundancy. Before Mars has hospitals, factories, schools, large farms, or cities. Before the word Martian means anything other than a dream. Those people may never return because the road home is too heavy, too dangerous, too uncertain, and perhaps not the point. They may never return because Mars needs them to stay. And if they choose that knowingly, if they understand what is being lost and still decide the future is worth it, then their journey becomes something larger than exploration. It becomes a kind of offering, not to Mars itself. Mars does not ask. Mars does not care. But to the future, to the possibility that humanity's story does not end on one planet, to the idea that every language, memory, child, city, and hope we carry should not remain forever vulnerable to a single world's fate. That is the civilizational realization hidden beneath the fear. Coming back may not be the deepest purpose. The deeper purpose may be making sure there is somewhere else for humanity to continue. And that is what makes the first Mars settlers so difficult to categorize. Are they victims of ambition? Are they pioneers? Are they volunteers stepping into exile? Are they the beginning of a second branch of human history? Maybe they are all of those things at once. In the final part, we will stand at the edge of that door, the one that opens from Earth toward Mars and may close forever behind the first people who pass through it. We will not pretend the future is certain. We will not pretend the sacrifice is small, but we will ask one last question. If becoming multiplanetary requires some humans to leave Earth forever, Will we call that tragedy? Or will we call it the moment home became larger than one world? So in the end, Mars is not only a destination, it is a test of what humans are willing to become. For most of our history, every journey has happened inside one world. Even when humans crossed oceans, deserts, mountains, ice sheets, and continents, they were still crossing Earth. The sky changed, the language changed, the dangers changed, but the planet beneath them remained the same living system. There was still air, still gravity, still weather, still water somewhere. Still the ancient comfort of belonging to the world that made us. Mars removes that comfort. It is not simply far away. It is elsewhere in the deepest possible sense. A place where every breath must be protected. Every meal must be planned. Every drop of water must be counted. Every wall must hold. Every machine must keep working. Every human relationship must survive the pressure of never being able to walk away. And if the first people go there knowing they may never return, then their journey will not be like Apollo. It will be more final. Quieter, perhaps, less triumphant in the familiar sense. No ocean splashdown, no recovery ship, no cheering crowd waiting on Earth. No moment when the astronaut steps out, waves, and becomes proof that the circle has closed. Instead, there may be a habitat under a red sky. A small group of humans standing beside a machine that keeps them alive. A delayed message sent back to Earth. A voice saying that they are safe. A pause of several minutes. And then, somewhere far away, a planet of billions finally hearing what has already happened. That is the strange loneliness of Mars. Even its greatest moments will arrive late. The first step, the first sunrise, the first emergency, the first harvest, the first loss, the first celebration. Earth will watch from a distance, always behind the present, always receiving the story after Mars has already moved on. And perhaps that delay will become symbolic of the whole relationship. Earth will always be there, but not quite close enough. For the first settlers, Earth may become less like home and more like memory. A blue world suspended in blackness, filled with everything they gave up so that something new could begin. Oceans they will never touch again. Forests they will never walk through again. Voices they will hear only after silence. Weather they will remember like a dream. That is why the idea is so difficult to hold. The first humans on Mars may not come back, but if they succeed, they will not simply be lost. They will become the beginning of a second human world. Their sacrifice would be measured not by the distance they traveled, but by the permanence of what they chose. They would trade return for continuity. They would accept that their own lives might be smaller, harder, more confined, and more dangerous, so that future lives could begin somewhere humanity had never belonged before. There is sadness in that. There has to be. To leave Earth forever is not a clean act of heroism. It is grief mixed with purpose. It is ambition mixed with loss. It is the human heart trying to stretch across a distance it was never designed to understand. But there is also something magnificent in it. Because if humans ever become truly multiplanetary, it will not happen because Mars was easy. It will happen because some people chose the impossible edge of survival and stayed there long enough for it to become ordinary. At first, Mars will be machinery, then routine, then settlement, then culture, and perhaps one day, home. A child may wake under artificial light and hear stories of Earth as the old world. A teacher may point to a blue star in the sky and say, That is where we came from. A family may gather inside a pressurized room while red dust moves quietly outside. Someone may plant seeds in a greenhouse and think nothing of the fact that their entire world depends on walls, power, and recycled air. What feels terrifying to us may become normal to them. And that is how history works. The unbearable becomes memory. The impossible becomes infrastructure. The exile becomes ancestor. One day, if Mars has cities, if human voices echo through tunnels and domes, if children learn to walk in its lighter gravity, if people argue, laugh, study, work, fall in love, grow old, and bury their dead beneath another planet's sky, then the first settlers will be remembered differently. Not as people who failed to return, as people who made return unnecessary. They will be the names carved into the beginning of Martian history. The ones who crossed the door when there was no guarantee it would remain open. The ones who gave up Earth not because they hated it, but because they understood how precious it was and how dangerous it is for all human hope to remain in one place. That may be the deepest reason Mars matters. Not because Earth is disposable. Earth is not disposable. Earth is the origin of every human breath, every memory, every language, every dream that will ever be carried to Mars. Leaving Earth should never mean abandoning it. If anything, Mars should make Earth feel more sacred, not less. Because the more we understand what it takes to keep humans alive elsewhere, the more miraculous our own planet becomes. Here, air is given. Water falls from the sky. Food grows from soil. Gravity holds us without crushing us. A magnetic field and atmosphere shield us quietly from space. We live inside a paradise so familiar that we often mistake it for ordinary. Mars will not let us make that mistake. Mars will teach, brutally and beautifully, that habitability is rare, that life is fragile, that civilization is not separate from its environment, but completely dependent on it. That home is not just a place we love, but a system that keeps us alive. And perhaps the first Martians will understand Earth more deeply than anyone, because they will know what it means to live without it. So, when we ask why anyone who goes to Mars may never come back, the answer is not only fuel, or gravity, or radiation, or cost, or launch windows, or psychology. The answer is that Mars changes the story. It changes exploration into settlement. It changes astronauts into founders. It changes distance into identity. It changes home from something inherited into something built. And once that change happens, coming back may no longer be the measure of success. Success may be a light staying on inside a habitat through the long Martian night. A plant growing where nothing had grown before. A child hearing Earth described as the place humans began. A community surviving one more season under red skies. A future that did not exist until someone accepted that they might never return. So perhaps the first humans on Mars will stand at the edge of a door no one has ever crossed. Behind them, Earth, blue and alive, impossibly generous, impossibly distant. Before them, Mars, cold and silent, offering nothing except danger, dust, and the chance to begin. And when they step through, the door may close. Not with violence, not with drama, but quietly, with distance, with time, with gravity, with biology, with the slow realization that some journeys do not end by going back. Some journeys end by becoming home. And if that is the price of humanity becoming more than an earthbound species, then the final question is not simply whether the first Martians will return. It is whether we are ready to honor the people who may leave forever, so that one day home can mean more than one world.